Hello, this is David Braun, and this webinar is entitled Practice, Practice, Practice. Here's my contact information. Let's look at the schedule. All right, this video is intended for anyone who wants to learn more about regression analysis. It doesn't matter what regression program you use. We will be using the Regression Plus software and a few special features in it today to accent dummy fields and curvilinear relationships. Okay, now be sure you've already watched video 1. I have a regression program. Now what? It's important that you do these videos in sequence. Before you go to the next video, you should perform 20 regression analysis, but keep them simple, just a handful of property characteristics, and the purpose would be only to find the value of the subject property. Don't worry about extracting adjustment rates at this time. Under resources, I listed some resources in video 1. Here's a book I forgot. It's titled A Guide to Appraisal Valuation Modeling. It is an Appraisal Institute book, so you should be able to go to the Appraisal Institute site and find it. It is by Lene, Kane, and Dell. It's a very good book because it's written for appraisers, therefore it is readable. Some of the terms that you need to be thinking about outlier, coefficient, intercept, collinearity, and multicollinearity. Now, we're not going to cover those in these little short videos. These videos are designed just to help you get using regression. But we do want to point out what you need to be working on. And keep in mind the 4 main categories that you need to be thinking about: scrubbing the data, market modeling, regression analysis, and residual analysis. So begin researching each of these topics. Some of these, like outlier, coefficients, you can simply go to Google and put in statistics, intercept, statistics, multicollinearity, and you will get some good information. You can also find information in the books that I've given you in the resource list. Now, what are we going to do on this video? We're going to approach the question of how to perform a regression analysis via an example. So we're going to do a regression example. We're going to present a list of steps in the regression analysis process. So we're going to get a list of steps in the process. You're probably going to want to write those down. In the 4 categories that we mentioned earlier, scrubbing data, market modeling, regression analysis, and residual analysis, we're going to focus on regression analysis, and we're going to talk about a list of steps to perform this particular analysis, the regression analysis. All right, let's think about our steps. The first step is we want to check the data. We're looking for blanks, we're looking for typos and errors, and we're looking for dummy fields that don't have any hits in them. Now remember, I don't expect you to necessarily understand what a dummy field is. You'll have a little better understanding after this video, but you're probably going to have to go and research it. Be sure there is only one variable that measures each property characteristic. Now, like in apartments, you might look at the building's square feet. You might also consider the number of units. Both of those are measuring the size, or the how big the property is, the building is. And we only want to use one at a time. So if you can bring them both in, but you'll have to only use one at a time. When you bring them both in, it sometimes helps you to look and you can figure out which one the market is emphasizing. But we only want one variable. So again, this is the list you should be writing down. Unselect one of each dummy field unless there's one of the dummy fields you didn't bring in. I typically bring all my dummy fields in. fields in and I just uncheck one. Some people leave one out in the beginning. All right, this is an A and B because I don't think it matters whether you do A first or B first, but one of the steps is, except for dummy fields, omit any variables where the coefficient is absurd. So if you're appraising a house and the value's coming out about 150,000 and it's saying the pool is worth 75,000, you know that's probably absurd, or the gross living area is valued per square foot at a negative $20. Those would be absurd. So appraisers know what an absurd coefficient is. All right, part B, omit any variables with high p-values. Okay, and we're going to cover some of this and talk about it in our example. Correct or remove any outliers. If any are removed, then repeat some of the prior steps. So you'd probably have to come up and once you've deleted an outlier, you're going to have to go back and do some of the steps again. Gauge the quality of the model based on the general outputs. And we'll look at that, because in regression there's the regression equation, and then there's some statistical outputs that help us confirm that we have a good model. If the model is good, it looks robust, then we just stop. We're done. If it's not good, we're going to modify the model and go back up, and we are going to go back up and start a little higher, and we may have to look for more outliers, and we're going to gauge the quality again, and we're going to go back and go again. So it's kind of an iteration. When we make a change, then we have to go back and go through some of our steps. Now, what do we mean by modify the model? We mean remove or add sales, or remove or add variables. So if we take 2 sales out, it's going to change everything. Then we're going to need to go back up and re-look at how good we think the model is, and if it's good, then we're going to stop. If it's not, we might try removing or adding some variables. Now, some of this, like I say, I don't expect you to know a lot about it today. You're going to research it, but we're also going to cover it in our example. So let's just move right on to our example. This would be a retrospective appraisal. Now, back in May of 2010, the tax assessor in my county said that values in Blount County had returned to their 205 values. Was he correct? Now, let's think about this. In our area here, our residential market tended to take the downturn sometime in the middle of 2007, maybe towards the beginning of 2007. Now, we stop at 2010. I think it was about 2012 before a lot of the markets began to level off. Now, my question was, is the tax assessor correct? Because I had this nifty regression program and I could check it out. Now, I can't check it out for all of Blount County. It's kind of a misnomer to think of a whole county as a market, or a whole state, or the national housing market. Those are kind of misnomers. But I could take one market. As a matter of fact, I took one great big subdivision, and because it's one subdivision, one location, very homogeneous properties, and these are all real data, I only needed the closing price, the closing date, the gross living area, and the age. So let's take these over to our regression program. And another thing, let's look at this date. I wanted to show you. It goes back all the way to 2001 and goes to 2010. So there's 8 or 9 years of data here. Now, normally you won't do this. You won't do 8 or 9, and I think this is the only exercise I've done more than 5 years of data ever. But in this case, I needed it to kind of see what was going on. So let's grab this data. I'm going to hit Control-All, Control-C to copy it. And let's go to the regression program. File. All right, and I've got to, when this opens, I have 3 screens, so these little windows jump to other screens, and also they're a little tight here because I'm coming to my smallest screen here to record. All right. Whoops, I hit the wrong one. I don't want to do it from a file. I did it from the clipboard. All right, now we have to scrub our dates because I don't want to use dates. I want days since sale, and it knows that it's the closing date. And we want to go back to April 15th, 2010. So let's go all the way back to 2010, retrospective. And we're going to go to April the 15th. Also, I'm going to create some dummy fields. Now, this is built in my Regression Plus software. Some of the software programs that actually load stuff into your file and do quite a bit for you are going to make something like we're doing here, probably even more automatic than we're doing it. Then there's going to be some, if you work in Excel, and there may be some other programs that you have to build these bins yourself in Excel. Either way, it can be done. But it's important to understand what a bin is. Now, what we're going to do is we're going to make a bin be 180 days. So if there's 8 years of data, that would be like 16 bins. All right, nothing else that we need to do here. And there's no other scrubbing to be done. Now, because I practiced this a minute ago, it brought these over for me. It's got the street number, the street name. It's got closing price in the dependent variable. And remember, it's simply, these things are all going to open up in the left, and you're just going to have to click and move them to the right. And then we're looking at gross living area, age, and the day since sale now, and the market condition fields, which is the dummy fields. Both of those measure the same thing. One of our lessons today in our steps is we can't use both at the same time. All right, now we're done here. And let's just go back to our steps a minute. Check the data for blanks, typos, and errors. Okay. Now, in my software, if there is a blank in any of these records, it will automatically unselect it, like it would come in like that, and whatever's blank would be in red. Now I can see, because I can order, if I click here, it's going to reverse the order, so I can see checked and unchecked. So they're all checked. So I know in my data here I have no blanks. Excuse me. Now typos and errors, one way I like to do it is get to the main entries, and I like to sort them from the low. There's 83,000 to the high. This is sales price to 210,000. And if this, for example, said 2 million, I would know that someone had accidentally typed a 0. So I'd want to fix that now. Gross living area, I can look at each of these, and all of these are okay. Now there's a lot of days here because this is like 10 years, like 8 or 9 years. Not really 10. I think it's probably 8.5 or 9. Now here are the dummy fields we created. Remember, we created a bunch of them because we did 8 or 9 fields, and each one of these represents, each one of these data fields represents 6 months. So I'm going to reverse these, and like this particular property, 1914 Ralston View, sold back in this first bin. Okay, it's important. Now if one's in the bin, we call that a hit, and I like to have 4 or 5 hits, but we don't always have to have it. I know there's only 2 in one of these because when I started to go, I got a message that said one of the bins only has 2. But the main thing is I don't want any bins without any hits. That's the main thing, and I'd like to have more than just 1. So I know there's one in here with a minimum of 2, and remember, this was something I was doing on my own. It wasn't for a banker, or it wasn't an assignment. So I'm just going to kind of move past this, and I would maybe do a more diligent check if it was a different scope of work. Okay, what's next? Be sure there's only one variable that measures each property characteristic. It's pretty easy here because we actually have 4. We have the gross living area, the age, the day since sale, and then all of these MCA dummy fields represent 1, so that's 4. The day since sale and the dummy fields both measure time. So we don't want to use them both at the same time. So these came in unchecked, and this one is checked. Age and gross living area aren't the same thing. In the intercept, you're going to study it. The general rule for right now is no matter what, we leave it checked. You wouldn't uncheck it. Okay, no matter what it looks like. Right now, the rule is you would leave it checked. Okay, what's one of the next things? All right, okay, now let's talk about this p-value for the day since sale. All of these are in green, so they're all good. Don't worry about this being in red. This is the deviation, how much the subject deviates from the data. And guess what? Because the sale date, this will almost always be red, because the effective date of the appraisal is almost always going to be outside of the range of dates for my comparable. So that's okay if this is in red. But I notice the p-value, it says, okay, day since sale. It says that there is appreciation. Now, all of them are going to be a little bit different. In the regression plus, it starts from the beginning and goes backwards. It's day since sale. It's going back. And the days from now back to the sale, if you go backwards, it takes off $20 a day. So if you were back and you came forward, it would be a plus. So this actually shows appreciation rate of $20 a day. Okay, and a low p-value. So it thinks, the regression thinks there is a linear relationship between day since sale and the value. Now the value in here, you notice we haven't entered our subject valuation. We have to click here and go enter the subject. But you know, we don't need a subject. We don't have a subject in this assignment. We're just trying to find out about value trends. This regression has to have something to run on, so it's just set to run on the average input. So it's saying that the typical sale, the typical house in this market was worth about $172,000. So we don't even care about that, but that's the only reason it might have come up. And if you're in a different software, it won't run. It may require you to put a subject in. If it does, put it in. All right, now what we're going to do is we're going to unhook this one and we're going to check these. I don't have a fast checker here because I don't normally do this many MCA fields. The data on and off, it has an automatic. You can hold the shift and you can do bunches at a time, because sometimes you have hundreds of records of data, and that's in there. I didn't bother to put that in here because I never do this many. This is the most probably I'll have ever done and ever will do. Okay, now one of the steps that we said was that in the series of dummy fields, you have to unclick one of them. Now you notice here the p-values are all in red, and it can't calculate the standard error. But if I uncheck any one, now it gives me p-values, and you can read the error. So you have to uncheck one. Right now I'm going to leave it checked because I want to see a chart. I'm going to go up here and look at the market conditions chart, and I see here this is showing a curvilinear. Now we have a conflict in what regression is showing me, because it thought there was a linear relationship. Now, if there was a linear relationship over time, it was saying that this is the linear relationship. It looks like a linear relationship, and a lot of times, even if there's a curvilinear relationship, it may not matter that much. In this case, it does matter because we need these down. So I think that it's curvilinear, and I am going to override it, and I'm going to do this. Now on this best fit degree fit here, I like to bring it down to the one that is the smallest but still tells the story. Like that doesn't really tell the story, so 3 is good. Now let's think about this in terms of what I said earlier. I knew that around 07 somewhere the market started down, which is somewhere right in here. So this is actually at the end of 07. This is showing this market went down, and it was still going down at the effective date, which is 4/15/2010. Okay, now I do need to now go get rid of one of the dummy fields, and what I would normally do is just click one off and on till I find one that makes most of the, I get the most green or the most low p-values, and this is good enough for now. So I'm going to go here to valuation. Okay, now I'm also concerned, we talked about our outliers. Now let's talk about our outlier. An outlier is almost always going to have a very high residual, probably the highest residual. A residual is the closing price, like this one right here. The closing price is 133,000, and our market predicted 145. So it would be the sales price minus the predicted price, this was 9% off. So a 9% off, it's going to be one of these up here or 9% down here. Okay, if it predicted almost exactly, like if one sold for 135 and the market predicted 136, it's going to be very close to this zero line of residual. So the ones that are the farthest away, we don't like. So I have 90 sales. I'm not too concerned about this particular one right up here. It's 16%. The worst one is this one. It's almost 25% off. Now I can go find it and delete it. I can find it down here and delete it, or I can just hit the remove outlier and get rid of it. Matter of fact, I don't like this 16. And remember, I don't want to encourage you just to snap, snap, snap on this remove outlier button. I'm doing it because I have like 19 sales. Or, I'm sorry, 90 sales, which I'm down to 88 now. If you only had 20 sales, you might want to go and try to look and see why those are off. Now, one of the reasons that our variance is so high in a market that's homogeneous probably is because we are only considering 2 or 3 things. We're considering gross living area, age, and we're considering time. We're not considering garages. We're not considering view. We're not considering condition. Now we are considering age, which may be a proximity for a proxy variable for condition. Okay, so we've taken care of our outliers. Now let's look at our trend, our market condition chart, and let's see if we had a true statement from our tax assessor. He said that somewhere right in here, the values were about the same as they were in 2005. So here's 8. So right about here is mid 2005. So in August, they were right here. So it's pretty much true. Around in July, August, and September, right in here, the values are about the same as they are 4/15/2010. So I would agree with what the tax assessor said for this market. Okay, now quickly for those of you that use the Regression Plus, you can adjust some sales prices in here. Let's just put one in. I'm going to put 01. Say that my comp sold in 01 of 2009. Okay, and let's say it sold for 124,000. Okay, basically we know that in so let's find it on this chart. 1 of 09 is right in here. And I'm going to click. Hopefully my cursor is showing you something. I don't see anything. But when I click, hopefully it showed you something. So from there to here, we expect it to come down. And over here, we see it said that it did. It came down 13%, and it gives you the amount over here. Okay, so you could put your comparables in here if you have some weird curvilinear line, and it would help you to extract or calculate. You've already extracted them here, but it'd help you to calculate the amount on a curved line. All right, so what else do we want to cover? All right, we talked about the dummy fields. We didn't have any bad dummy fields except down here in my market conditions analysis. I think I had a couple in red. I'm not even going to worry about that down in that many dummy fields. Are the gross living area and age, are they, it says that for every year take off 1246. I'm okay with that. And the gross living area, take off $66. Okay, that sounds reasonable to me. And like I said, we're not worrying about the intercept right now. We're not worrying about the intercept. All right, so we remove some outliers. Now, let's talk about our model. How do we feel about our model? Now, there's 2 things here in regression, in a regression analysis. One is the regression equation. That's just a calculation. But also then we've attached some things like R squared and adjusted R squared. Adjusted R squared is the one you care about. And it's 0.78. That's really good. That's because this is such a homogeneous neighborhood. When you're just finding values, a low adjusted R squared, maybe even 0.5 may be fine. Now, when you go to extract line item adjustment rates, we're going to want that, we want the adjusted R-squared to be a little bit higher. So sometimes we worry about that, sometimes we don't. This particular one is just in my software. It's the Anderson-Darling normality test. Now, your software may allow you to make histograms to look for the normality, or a different test. It wouldn't matter. Now, with 88 observations or sales, these are my sales observations, I don't think the normality test even matters. I don't care what it tells me. I'm fine when I have that many sales. But if I was doing 12 sales or 15 sales or 22 sales, I might care about that, because normality affects the p-value. It also affects the confidence intervals. So if I'm relying on p-values and confidence intervals, that's going to be important. Now, the number one thing that I'm concerned about especially when I'm just finding values, not worried about line item adjustments, is the residuals. We talked about the residual earlier. The residual is the sales price minus the predicted price by the model. Okay, so we test that a couple different ways. Number one is we would like to see about as many above and below. Like right now, we're 20% off here. We can't see here, but we're 15. We wouldn't want to be 30 off here and 5 off here. So that's one way. There's the balance. We want about as many below and as many above. The other thing is what is the average of all of these differences? All of these little dots is a plotted residual as a percent of the sales price. So here the average was 5.3%. That's really good. But the average doesn't tell you about the spread. If you have a bunch, like you might have a 8%, and you might have go from 25% up here to a minus 25% there, and that spread's just too much. Now, to measure the spread, we can just look. We can see we only have a couple really bad ones. Most of these are between 9, probably plus or minus 10% would cover most of these. We can see that, but the coefficient of variation helps us. It's 8%. So that helps us a little bit. Now, I don't know that I've covered all of these, but if we made a change, like if we took off, we decided it wasn't good and we undid this, we would relook at everything, and we would kind of go through these steps again. But we do want this age in. Now, I'm going to look at the, this is in order to print the report out that goes in your work file or in your appraisal, in the Regression Plus, you have to answer these. Now, the reason I'm putting these up here, these are good things for you to think about no matter what software you're using. What the number of observations, the quality and accuracy of the data. I have some appraisers that tell me their MLS data is just terrible and that they have to really do a lot of work to correct it. And so if you know that, you know how much you corrected it, you have an idea about this. The model's prediction accuracy, and that's probably more to do with the residuals. The subject's fit to the data. We didn't care in this exercise. There was no subject. Reasonability of the model's output for the characteristics. That's the coefficients. Weights applied by the model to each of the property characteristics. What about your standard error and your R-squareds, your p-values? Were there any curvilinear issues that you have but you didn't deal with? In this case, we had one. It was the change in value over time was curvilinear. And then you have the Anderson-Darling test. Didn't apply to this one. And then we would think about our overall. So that's just a good list for you to think about. Now, in curvilinear, one thing that we didn't check, and your software may or may not have a way to check for curvilinear, we'll look for it here. This one does have a test. Now, these tests aren't standard. Some of you are going to have 5 or 6 things that I don't have here. I picked out the ones I thought appraisers needed, but these aren't the only ones. They may have other things that relate to p-value that they want you to look at both. I decided if you look at p-value, you don't need to look at some of the other things. But at any rate, let's look here at the trend analysis. Okay, now right now gross living area is checked, and this is kind of a residual test. And I can see that I've got an error of almost 2% here, and it goes to almost 2% here. If these errors are under 3%, 3% or less, we don't care about them. If they're over 3%, we're a little concerned. At 5 and 6%, we probably have a curvilinear situation that we can either deal with or not deal with it, but at least we know it's there. What about in age? And that's really good. This is not much. It's less than 3%. I'm not going to check these. So we didn't have any curvilinear. So I like this model pretty good. I do think it tells the story. I do think the tax assessor was pretty well correct. The values today are about the same as they were back in 2005. Okay, so make sure before you do the next video, video 3, which is going to start probably a 2-part series on extracting line item adjustment rates. Before you do that, I want you to get through 20 of these regression analysis based on finding the value and comparing them to a property that you've already appraised. Maybe the first 10 don't get into the market conditions, don't get into those at all, and then the following 10 get into those. So you got to have that experience. All right, that's video 2, practice, practice, practice. Thank you.